Can you all hear me?
Yeah. Yeah.
All
Yeah.
right, let's get started now. My name is Tian Huang, and I'm the founder and president of the Apping Club. And I would like to welcome all of you guys to the class 1 of the Apping Club Thanksgiving Crash Course. Today's theme is a combination of computer vision AI and MIT App Inventor. So before we get started, I would like to give a short introduction to Apping Club. So first of all, we're a global student-led nonprofit organization based in the United States of America, dedicated to impacting students and empowering students to uplift their local community through creating apps. We believe that everyone, regardless of your background or like what you have learned in computer science, that you can become an impactor, a factor to the society's future. So how do we do this? We host various events from conferences to crash courses like this, in-person workshops, and also various forms of online event and open source curricula to support students in the learning of computer science education and also early artificial intelligence education. If you haven't already, we heavily encourage you to join our Discord server and also check out our website, because our website have the links to all of our social media accounts. Usually our class recordings will be posted on our YouTube channel, so if you missed the class, you can check it out there. And all of our social media announcements regarding events or other activities or achievements will be posted on our Twitter and also our LinkedIn. As an example, here's the post for the Thanksgiving Crash Course from this year. Aside from that, our Discord server link is over here. We currently have over 500 plus members in our Discord server, so it's definitely a pretty thriving community of fellow app innovators. But as always, let's get started. And today, our teacher will be Haley Chung, one of our Apping Club officers. All right, but now I'll pass the mic to Haley.
My name is Haley. I'm a junior and I come from New York City. And let me just reshare. So as a start, as a little bit of a run through, first of all, I am going to be talking about a little bit about the history of AI, and then I would go into the fundamental of how AI work, etc., etc. And then I'm going to go we're going to have a hand-on course using MIT App Inventor about how we can implement AI into our apps. Okay, so as a short history class, so although the word computer was first uttered in 1897, the first known computer in history is called the Antikythera mechanism. It used layered of gear wheels to predict the motions of the solar system. The birth of modern computers, on the other hand, are catalyzed by World War II, where Alan Turing from Britain saved countless lives by building the first sophisticated computer to decode Germany's encrypted messages. This is the computer over here. This is what computers looked like 100 years ago. It is called Bomba. And something that's really interesting is that when computers still looked something like this, Alan Turing had already saw the vast possibilities of what computers can bring and saw that machines may one day mimic the complex emotions of humans. In 1950, Turing published a paper named Computing Machinery and Intelligence, where the concept of artificial intelligence was first brought up. In it, he predicted that by 2000, computers' behavior is going to be indistinguishable from a human one. And he is not far off. So also in 1950, Claude Shannon had already built one of the first robots that uses machine learning. It was shaped like a mouse, and it was trained to run through a maze from start to finish. As you can see here, the first image showed the path that the mouse took in the first run-through, where it made some mistakes there, here, and there, but on the second run, the mouse ran through the maze using its shortest possible path. Then we can see machine learning starting to exceed human capabilities. From 1996 to 1997, in a chess tournaments that lasted for more than a year, IBM's Deep Blue beat Garry Kasparov 3.5 to 2.5. By the way, for anyone who don't know, Kasparov is still considered the best chess player that the world has ever seen. How smart the computers are almost incomprehensible to the human brain. They can calculate math questions in the billionth of a second, and we couldn't know how smart computers can be. We cannot really comprehend it because they were only limited to certain subjects. Imagine everything we do in life as games. Those games has rules. Math has a really simple rule. You can add things together or you can divide them and you put out an answer. Therefore, computers pick them up pretty fast, and calculators are better than humans for like decades now. The game of English, let's say, on the other hand, have an exponentially harder rule to play to. Even ignoring the grammar rules that like humans don't even understand, scrambling 26 letters in one combination can mean one thing, and another combination can mean another thing. And there are things like exaggeration, sarcasm, tone, simile. We could not explain those rules to a computer. So we thought that they couldn't beat us in that game. Then we did explain those rules to them just recently. So the AI boom started in the 2010s. It included facial recognition, automatic driving, translation between languages, etc. And in September 2022, Jason M. Allen used AI to create a painting, and it looked like this. It won first place in the Colorado State Fair's annual art competition, the digital arts section, in November 2022, OpenAI dropped the first edition of ChatGPT. Those are called generative AI, and contrary to normal internet search, ChatGPT can give you an answer like how humans do. They give you paragraphs in response instead of pages and pages of articles. They start to think like how, or start to mimic to think how humans think. In May 2024, Guangzhou set up the world's first fully automated River Sea Railway multi-function dock, and that reduced manpower by up to 70%. Okay, so after all of this, how does AI even work? So computer science, or the machine learning, is broadly split into three parts. So the first part, which is generally considered the simplest, is called unsupervised learning. And then there's supervised learning, and reinforcement learning. So starting at the simplest one is unsupervised learning. So there are three things. The first one is clustering. Clustering is fairly simple. Let's say I want my computer to categorize these circles for me into two groups. It would try to find patterns, and they would say something like some are red and some are brown. Actually, it would say something more like this. That is how computers think, comprehend color in a hex code. And so they group these two together, and ta-da! And however, usually it's more complicated than that. Dimensionality reduction tells the computer to only focus on one part of the data so it won't get confused on another thing. Let's say shapes. Or you don't even need to tell it what shape it is. Then it would be easier for the computer to give you the answer. This is really energy saving and time saving. This is called dimensionality reduction because you deduct one dimension or perspective that the computer will think about. In this situation, the dimension that you redacted is shape. Here's an example of unsupervised learning. On the left, for now, let's keep it like this. On the left, you can see that there's the data that you would feed to the computer. On the right is the grouping or segmentation of the data you gave them. Using clustering, you can see patterns or differences we couldn't see otherwise. Maybe the red cluster leads to a mutation of the disease that leads to more infections and more severe symptoms. The similar logic can be used in market analysis in a supermarket, and also species identifications in biology, let's say. Let's see if the presentation works. And there are other things like association. One last thing that the unsupervised learning can do. Association is to find a pattern or connection from a huge, vast amount of data. One example is the Spotify song recommended. Let's say that you're really into pop music, like Taylor Swift. And Spotify knows that because you've been listening to a lot of Taylor Swift on their app. Spotify will identify you as one of the Taylor Swift listeners on their app. Then one day, Spotify noticed that other Taylor Swift fans started to listen to another artist as well, like Billie Eilish. Knowing that Taylor Swift fans like songs from Billie Eilish, the algorithm will then start recommending you Billie Eilish songs. Spotify here associated with you with Taylor Swift fans and assume that you and other fans probably have similar musical taste, so they would also personalize your taste as well, associate your taste as well, like associating you skipping songs as disliking a song and adding songs to your playlist, let's say, as liking them. Now let's go to supervised learning. So supervised learning involves feedback. Instead of AI trying to find patterns and grouping data accordingly using their logic, we as humans try to teach them a pattern we want them to follow. Unlike unsupervised learning, supervised learning would receive labeled data, which is basically data that has a note on it telling the computer how it should interpret the data. For example, we can try to train computers, and we succeeded, to learn to read handwritten numbers. In order to do that, we give them countless data to train them. See the countless data as flashcards you use to remember your Spanish vocabulary in school with the correct answers written on the back. Similar logic can be used to forecast the future. You could input data from the past, like stock market, for example, where this event leads to a rise in stock prices and that event leads to a fall in stock prices. And the computer will use those to predict the prices in the future and with maximum accuracy, and that might maximize the profit that you're gonna make from it. And let's go to reinforcement learning. Supervised learning is giving the computer labeled data. In reinforcement learning, it would create data themselves, and we would label them after the data was created. Reward them if they did something right. This is used when we ourselves are not sure of what the correct answer is, so we just let the computers figure out themselves. One example is walking, let's say. It's actually really, really hard to describe how to walk. The angle of your knees, let's say, and the muscle contractions, the keeping your balance. It's just a thing that every human needs to figure it out yourself. And, well, we also train the AIs to figure them out themselves. That's just a snippet of it. As you can see, that we could not really give them general procedures on how those works. So every time, let's say that within this video, that's the simulated figure falls down, then they will try again and then try to fix up something that they might have done wrong. And that is really similar to how us humans learn things. And that is also the essence of machine learning, teaching machine to learn how a human does. And that can be really useful when it comes to connecting between humans and AI themselves. And this is one of the simplest algorithms used in unsupervised learning. It is called K-means algorithm, and we will just watch this video to explain what happened.
Imagine you had some data that you could plot on a line, and you knew you needed to put it into 3 clusters. Maybe they are measurements from 3 different types of tumors or other cell types. In this case, the data make three relatively obvious clusters. But rather than rely on our eye, let's see if we can get a computer to identify the same three clusters. To do this, we'll use k-means clustering. We'll start with raw data that we haven't yet clustered. Step 1, select the number of clusters you want to identify in your data. This is the k in k-means clustering. In this case, we'll select k equals 3. That is to say, we want to identify 3 clusters. There is a fancier way to select a value for k, but we'll talk about that later. Step 2, randomly select 3 distinct data points. These are the initial clusters. Step 3, measure the distance between the first point and the 3 initial clusters. This is the distance from the first point to the blue cluster. This is the distance from the first point to the green cluster. And this is the distance from the first point to the orange cluster. Well, it's kind of yellow, but we'll just call it orange for now. Step 4, assign the first point to the nearest cluster. In this case, the nearest cluster is the blue cluster. Now we do the same thing for the next point. We measure the distances, and then assign the point to the nearest cluster. Now we figure out which cluster the third point belongs to. We measure the distances, and then assign the point to the nearest cluster. The rest of these points are closest to the orange cluster, so they'll go in that one too. Now that all the points are in clusters, we go on to step 5. Calculate the mean of each cluster. Then we repeat what we just did, measure and cluster using the mean values. Since the clustering did not change at all during the last iteration, we're done. Bam! The k-means clustering is pretty terrible compared to what we did by eye. We can assess the quality of the clustering by adding up the variation within each cluster. Here's the total variation within the clusters. Since k-means clustering can't see the best clustering, its only option is to keep track of these clusters and their total variance and do the whole thing over again with different starting points. So here we are again, back at the beginning. K-means clustering picks 3 initial clusters, and then clusters all the remaining points, calculates the mean of each cluster, and then reclusters based on the new means. It repeats until the clusters no longer change. Boop, 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 boop. Now that the data are clustered, we sum the variation within each cluster. And then we do it all again. At this point, k-means clustering knows that the second clustering is the best clustering so far, but it doesn't know if it's the best overall. So it will do a few more clusters. It does as many as you tell it to do, and then come back and return that one if it is still the best. Question: how do you figure out what value to use for k? With this data, it's obvious that we should set k to 3, but other times it is not so clear. One way to decide is to just try different values for k. We'll start with k equals 1. K equals 1 is the worst case scenario. We can quantify its badness with the total variation. Now try k equals 2. K equals 2 is better, and we can quantify how much better by comparing the total variation within the 2 clusters to k equals 1. Now try k equals 3. K equals 3 is even better. We can quantify how much better by comparing the total variation within the 3 clusters to k equals 2. Now try k equals 4. The total variation within each cluster is less than when k equals 3. Each time we add a new cluster, the total variation within each cluster is smaller than before. And when there is only 1 point per cluster, the variation equals 0. However, If we plot the reduction in variance per value for k, there is a huge reduction in variation with k equals 3. But after that, the variation doesn't go down as quickly. This is called an elbow plot, and you can pick k by finding the elbow in the plot.
Okay. So this is just a small introduction to the algorithms behind everything. So now, as a bit of a review, I'm going to ask you guys 3 questions. I would have 3 scenarios, and I want you guys to tell me in the chat what type of machine learning that would be. Okay? So first of all, the first scenario is that an algorithm, realized that people in a shop who buys magazine would have an 89% chance of also buying peanuts. I would give you guys 30 seconds to think. The answer is unsupervised, and yes, it is learning by association. Great job. And scenario 2, your car is driving by itself, and then it realized that there is a tree in front of the car. Your car decided to press on the brakes, and the car stops before hitting the tree. What algorithm or machine learning type would be used to train that? And the answer is reinforcement. Great job. Okay, and last but not least, let's not notice that there's only one type of machine learning left. But let's say that we have 4 weeks worth of rain already in New York City, and we realize that there is a wind from the south. So the algorithm, I'm just making this up, but the algorithm realized that that means that tomorrow we have only a 0.3% chance of raining. Would it be supervised, unsupervised, or reinforcement? Great job. Okay, it is supervised. So this tells me that you guys are listening, which is really cute, which is really great. All right, so this wraps up the first half of the lecture. Actually, never mind. So as not really quickly, as the last section of the lecture, and then after this, we're going to be working on the MIT App Inventor. We're going to talk about ethics, because ethics is indeed a really huge part when we talk about AI. It has a lot of debates. So first of all, because of the new and rapidly growing generative AI, it has a huge ethical battleground right now. So because that AI can only mimic human emotions, any form of art, either writing, painting, is a way for humans to connect with each other. However, AI's writing is merely a remix of past ideas that they've seen before. This problem is worse when it comes to AI art, because a lot of the art pieces people use to train the AI in machine learning is copyrighted, and those art pieces are being used without the artist's consent. Would that break the copyright rule? But it doesn't. But isn't that like also what other humans do? Remixing ideas that they saw in their daily lives and other people's work, and then making it into their own work. Why would that bad when it comes to computers? Why would that be bad? And second of all is accuracy. So in March 2024, Google's Gemini paused its AI image generator feature after it depicted historical figures like the founding fathers and the Nazi soldiers as Black. This is because of the huge amounts of information that they're trained on, and those informations, a lot of them may be wrong. And now that AI may become a large source of misinformation as well, especially when we have an AI overview every time we search something up on Google. And lastly, we have humanity. When would AI chatbots be considered human? It already passed the Turing test, which if you remember from the start of the lecture, means that its behavior is already indistinguishable from a human one. And should we started treating them like human? And I'm pretty sure. Yep, this is the first half of the lecture, and we will have a 5-minute break before we come back and talk about MIT App Inventor. All right.
Okay, now actually coming back from the break, I would like to talk about one more thing, touching up on the AI ethics part. So hopefully you guys are back from the break. It's already 43 now, so it's been over 5 minutes. So I'd like to mention more on the side of the benefits and also the risks in AI, especially generative AI. As in the current world, we're surrounded by large language models. For example, ChatGPT, Cloud, or like even Anthropic, Llama, etc., right? And in all of these AIs, they are all threatened by one major limitation, aka hallucinations. Responses are very plausible but are actually factually incorrect. And these can cause a huge amount of decimation of misinformation and also the spreading of false information and perpetuating it because it gets more and more. So it just like continuously grows. And what this causes is it causes concerns in fields, for example, the news industry, causing concerns in deepfakes, generating false information images, and also privacy issues, consent, copyright, and etc. Even though that AI brings a lot of benefits, such as streamlining a lot of processes and supporting the task completion for a lot of industries, it is very important to be mindful of these limitations and risks that are inherently there in the large language models. And this is more like you will be able to understand it more about like why this risk exists, why large language models have hallucinations if you're able to learn more about how the structure of the model works. As if you will learn that in like the transformer model proposed in the Attention is All You Need by Waswani, you will see that after all, it's basically just three multi-head attention layers stacked together, feeding into a softmax layer, which basically generates this probabilistic prediction. All right, but with the computing stuff aside, I'd like to mention ways that you can actually contribute to the field of making AI safer, contributing to AI ethics. So first of all, UNESCO themselves have proposed the AI competency framework for students. I heavily recommend you to check this out because it entails all the information that you will need to know about how to thrive and safely use AI. As you know, since we can't really avoid AI because we're literally surrounded by it every single day, then why not embrace it and support the learning and education of proper usage for AI at a very young age for students, right? So that's the goal and the mission of this framework. So I heavily recommend you check it out. It's available on the UNESCO website, and I will send the link in the chat. And also, UNESCO also hosts the Digital AI Learning Week every single year during September in the headquarters in Paris. And this is also an event dedicated to developing a competency framework for students and teachers on AI ethics. Aside from that, I would also like to mention that Apping Club, we're partnered with the App Inventor Foundation, which you might be familiar of if you heard of MIT App Inventor. And MIT App Inventor is one of the world's largest educational app development tools, with over 20 million users. But recently, I'd like to mention that they introduced a new initiative called the Educator Collaborative. And in this collaborative, the goal is to help teachers to be educated about AI, help teachers to be trained to teach AI. So in this like program, we offer a free and open source curricula, free professional teacher training program, and also this community of teachers to engage and promote the teaching and education of AI. So if you know government officials, if you know like teachers or administrators in your area, especially if you live in California or Massachusetts, feel free to send them this link. Feel free to tell them to sign up, as the sign up link is public. And also, signing up does not bind you to any like responsibilities. So they can sign up, and if they don't want to do anymore, they can back out any single time. So I'll be sending the links to these three in the chat. And also, if you know any like government officials, especially in the education sector, feel free to contact me personally on Discord, as I am also part of App Inventor Foundation, and we work on promoting this free teacher training program to teachers all across the US. All right, with that said, I'd like to give the mic back to Haley, and she will be walking you through to the rest of the class on using MIT App Inventor to create your first AI chatbot app.
All right, thank you, Tony. So Tony had already given a introduction to what MIT App Inventor is, so let me just give a more official one, let's say, in this class. So MIT App Inventor is a free open source web platform for anyone who wants to create mobile apps who lacks accessibility to the best resources, because those things usually cost money. And it is a really easy way for you to get your first experience on coding and for you to think like a coder, where you would use block codes instead of like typing out your things, because that would be easier and it would feel less overwhelming. It is backed by 10+ years of research from MIT and Google, and it's just 1 year of learning, engages learners as technology creators and not just consumers. And lastly, of course, it helps inspire programmers effect change in their communities. Okay, so let's start on doing that. I would start on what we're doing. First of all, let's have a setup. This is a fresh Google page that I have, and then what we do is you type MIT App Inventor login, or you can click register. And what you do, let's just go to the login page. That's what I did. And then after you came to the login page, there is an option that is create an account. So you click on that. And then you would be asked for your email address. Fill that in. And then they would send you a link. And this thing, if you don't allow it, it sometimes wouldn't work. So I would recommend you allowing that. And you should just sync the link and the code. And then the link should, and then the code should come into your inbox. Sorry, that wasn't simple. And then you would just read the terms of service, and then you would come into this page. Hopefully that delay means that the other people are finished. If you're done with this step, would type like 1 in the chat or something. Perfect. Okay. So I shall continue. So for today, we are going to make an app that incorporates the Google's Gemini into MIT App Inventor, and then we're going to use its camera features, and we're going to ask Gemini what ingredient is in our food or Thanksgiving. Or actually, if you after you understand how we do it, you can essentially ask the chatbot any question that you want. So we click new project. We have a project name. Let's just call it food recognizer. Okay. So you're in this page, And the thing about MIT App Inventor and like why I like it so much is because that you can have so much thing that you can do, and then you know that just when you look at the palette. And this thing might overwhelm you at first, but like it's really, really cool. So first of all, you have a button, which like after you drag it over here, you can click it in your app, and then you have a checkbox, blah, blah, blah. You can also have media, which like camera, which we're going to use today. Let's say sound, and then text to speech. And we also have drawing and animation where the ball can move within your app and then they can bounce off of walls, etc., etc. There's also data science, which is really cool. Sensors have things like clock where they would count how many seconds whenever you want them to count. And there's also even thermometer, which can sense like what temperature it is around you. So anyways, point is that it has a lot of things, and almost everything that you can think of, which is great. So first of all, we would have a text for button 1. This one is going to be the camera picture, and then after you click this button, it should go to the camera feature and take a picture. And in order for this thing to do that, you also need to go into media and then you drag camera into this thing. And because it's non-visible, it would go into here. It's not gonna be within this. So yeah. And then after you have the picture, right, you have to put it in to Gemini and ask the question. Therefore, you would have another button, and then you can have the background color. You can change anything you want and the size. And then we go down here. If you want, you can change the text, and I will change it to take a picture. Okay. And then the text for button 2 can be ask question. Okay. And then after you take a picture, you want to see the image, right? So we can also drag the image box down here. However, the computer isn't linking the button to the image yet, so we have to code that later in the code section. So afterwards, you can drag in a label. And this label is going to be the response that Gemini is going to tell you. Oh, and if you have like a question or anything, definitely feel free to ask in the meeting chat box, and either me or one of the co-hosts or Tony can answer the question there, because I think I heard something, but I'm not sure. And after all of them is done, actually not all of them, because within the MIT App Inventor, you can go to experimental, and then there's a chat box feature. And yeah, just click OK. And this is all of the components that you're going to need for this app. And actually, I'll go to that later. And this is like let's say we're in a cooking show. So right now you just got all of your ingredients ready, right? So now when we go to blocks is when we're actually going to organize the ingredients so then it can turn into a runnable app. So first of all, you can go back to it and then you can see that the first step is to take a picture. So the take a picture one, of course you can also rename it because it might make your life easier when you have a bigger app. But now because we only have like 5-ish ingredients, I will just skip that stuff. You will click the button 1 button and then you will drag out one button 1 click. It's basically telling the computer when someone click this button, you have to make this reaction. So then you would go to call camera 1 because this is what button 1 should be designed to do. And then you say, when this button is clicked, you have to call camera 1 to take a picture. Okay, so now the picture is taken. So now, and then they would store that data of the picture somewhere within the MIT app, somewhere within your app, and you want to visualize it. So you click over here and then you say, when camera 1, after you take a picture, what should you do about that data, right? And then this is why we have image 1, so then it could first show you what the image looks like and also make it into a variable that you can use in the future. So we set the image 1 picture to, and then when you click this, you can get image. Okay, I'll wait here. If you are up to my step, say 1 in the chat. Okay, oh no. Perfect. Okay, so now if you like visualize what the code is going to do, okay, so you're a user of your app and you're like, oh, I want to take a picture. So you clicked button 1 and then the camera took a picture for you and then you can see what the picture is in your image 1. So now you're like, oh, okay, so I want to use this picture and ask a question to the chatbot. So you would go to button 2 and then you would say when button 2 click, right? And then you would use the chatbot and then you would go to call chatbot 1 converse. Converse sounds like a fancy word, but it basically means ask them a question or start a conversation with someone. So you need to converse with image because you have your image 1. So it's not converse without image. And then for the source, you just use your image 1. And then you go to your text box. There's this thing, and then you can ask them a question. I will say, and then they won't know what ingredient it is. So you go to image 1 and be careful, you do not say image 1 itself, because if it is image 1 itself, then you would give the chatbot all of the information about that image, which includes the height and then the rotation angle, the scaling, blah, blah, which like the chatbot don't need it. So you only put image 1 dot picture because that's the only thing that you want them to focus on, which is dimension redaction. Anyways, so this is button 2. And then you would go to the chatbot and then you say when the chatbot got response, you would use label 1 and then you would set the label 1 text to the response text. And that is all. It's just that simple. And then after you finish all of this, I forgot, you have to have the MIT, what is it called? You have to have the MIT AI2 companion. So if you do not have that, you can, yeah. Tony just sent in a link and then they will help you get the app ready and check. And the great thing about this app is that you can test yourself using connect button, the AI companion, to see what like you actually created. Yeah. I will wait for 2 minutes. Or if you're ready, you can press 1 in the chat. And um, this is just a thing that's going to like look at my that's going to broadcast my what I see on my phone. After you finish this, you go to connect AI companion, and then it would show you this page, and then let's do mirror. Okay. What you're going to see after you have the code, you click scan QR code. Okay, let me stop share first, and then let me do some problem solving. I'm going to make it so that you can see both things on the same time. Yeah, like this. And then you share the screen. Okay. So now you have this thing. Let me make it so that this thing can work better. Like this. And then you aim it at the QR code. And then this is the app you made. So you click, take a picture, and then it would go to this screen. This is my pear. Let's take a picture of my pear. And then they would show you the image that you took because of image 1. And you ask the question of what ingredient it is. And then it gives you an answer. The answer, it might not always be the most accurate because this is a type of fruit. But yeah, it's really cool. When you say what do you do again, like which aspects are you referring to? Let me just share this. For Elon, Tony have a link in the chat, and then they can help you there. For the unrecognized methods, So a way for you to know like what exactly went wrong. I'm thinking if that method might help or not. You can go to chatbot, and then there is a thing called when error occurred, and then there's response text, which is going to further make your make like the error thing clearer. And when it says unrecognized method, I never it might be because that it is still in an experimental phase. So Converse with image is still like it's one of the newest things that they added 2 weeks ago, so it might have some bugs there. Sorry, that's not the best answer, but some other things may be that the chatbot should be set to Gemini because ChatGPT you need an API key and then it might malfunction. So and the provider should be ChatGPT. I believe that the course is recorded already, and then it would most likely be aired in the MIT App Inventor official YouTube channel.
I'll clarify, it will be the Apping Club YouTube channel.
And just to add, because that this thing basically limited the question, we can even make it more interactive with the user by adding this thing called text box. So if you add it here, and then you replace the question of what ingredients is in this food with the text box text. Which means that now if you open your app, you can ask the question yourself with the Gemini, which makes it more interesting. If converse with image is malfunctioning, I'm not sure. I think that I would try just converse and see what happens after that because I really can't have a better answer than it. So sometimes it might bug a little bit because of how new of a feature it is. So try converse first and then ask the question. Okay, I think that we will end the class here. I hope that you guys enjoyed and I hope that you guys learned something from it. And if you have any further questions, definitely go to the Discord server and we can discuss over there. All right, thank you so much for tuning in, and I hope you guys have a nice Thanksgiving.